is about how to convert state space to transfer function, and also how to convert transfer function to state space. This is modern. This is conventional. In order to convert state space to transfer function and transfer function to state space, we just use formula, that's all. That's the only thing that we need to do. We have a formula in order to convert state space to transfer function, that's all. So, in this case, I will show you how we get that formula. Please remember how to get this formula. Okay. In order to get this formula, state space is x dot ax plus bu y equal to cx plus du. Alright? And then the transfer function is, the definition of transfer function is what? Output divided by input. In this case, the output is labeled as y. Is it correct? So that's why the transfer function will be ys. And then the input is labeled as un. So the input here should be divided by us. So the definition of transfer function is, which is output divided by input. So what we need to do, we need, because this is in time domain, or maybe I can write in time domain, in ax plus but cxt plus dut yt x dot t. This is the correct form. However, in exam or anything during the class, we don't need to put the t lah. I hope you will automatically know that actually there is a t there. Okay. How we want to convert t to s? What we need to do? Yeah, we need to Laplace lah. So in this case, in order to convert this one to s, we just need to Laplace. Laplace. We need to Laplace. No. Should be here. We need to Laplace. Then we get this one. Okay. According to Laplace table, x dot t, or we can write as dx over dt. When we Laplace, we get sxs. You can see how many d here? Power 1. So that's why every time we have d over dt, actually give you 1s. If you have d power of 2 dt square, you get s square. Okay? And then after that, xt become xs. That's how we Laplace thing. According to table lah. Kan? According to table lah. And then a, is it we need to a will become a. Because there is no related to time. Xt become what? Is there any d over dt here? So the s, because there is no d over dt, s power of 0 lah. Because there is no d over dt kan. Xt become s power 0 equal to what? 1. Anything with power of 0 equal to 1. So here you get x s. Similar to this one. Ut you get u s. We skip this part lah. Ut become us. Here yt become ys. Xt here. Ut already there. Okay. So what you need to do, you just replace lah. At the first equation there, x dot t become s xs equal to A, xt become xs plus B, ut become us. And then here yt become ys equal to C, xt here xs plus D, ut become us. Okay. So we Laplace these two equations. Our target, we just want to find ys over, this is our target. So we need to rearrange this equation until you get ys over us. That's all. The best thing is, this is your ys, kan? Where is the equation have ys and us? Ys and us. This is the equation we have, kan? So the best way, we need to plug in, we need to put equation number 1 into equation number 2. Because equation 2, you have ys and us. So we need this equation. So we need to put equation number 1 into equation number 2. How we want to put it? Is there any excess inside here? So we need to eliminate excess. We need to remove excess, is it? So now, in this first one, we need to make xs as the title. So from 1, you can see s xs, and then you put it there, will be a xs plus equal to b us. And then you need to factorize xs. S minus A equal to B US. Okay. There is a trick here, some modification you need to do. What is the modification? S is one thing, only S. S, A is a matrix. Is it correct? A is a matrix. Let's say A matrix is only 1, example. So S minus 1, so here S minus A, kan? S minus A, since A equal to 1, so S minus 1. You can solve it. Let's say we have A equal to 0, 1, 1, 0, example. So here we have S minus A, the S minus the A, 0, 1, 1, 0. Is it can be solved? Cannot. The matrix only can solve if this one have the same dimension. Okay? So that's why, how we want to make sure this S can turn into the same dimension. So that's why we need to put this one identity. Identity, yeah? What is the meaning of identity? The form of identity is 1, 0, 0, 0, 0, 1, 0, 0, and so on lah. 0, 0, 1, 0, 0. So it means that the diagonal here, 1. The rest is 0. Okay. So it means that if this case, this is 2 by 2 matrix of A, so your identity only this one lah. So it will be S, since we have identity here, will be 1, 0, 0, 1. Is it can be solved? Yes. So that's why we need to put identity here. Is it correct? Is it clear? So that's why Si minus A. All right. And then finally, you get XS. You need to put it down there, is it? Okay. But once again, because this is matrix, you cannot simplify put B over S minus A US. No, no, no. Because this is matrix. In matrix, if you want to put it down there, so it will become Si minus A inverse. Okay, I write again. You put it down there. You get B US over SI minus A. Kan? Actually, SI minus A ni, if you write down, is also same with the SI minus A inverse. This one, B US. Same thing. If you still remember, if you have 1/3 actually equal to 3 inverse. Is it correct? Same thing, kan? If you have 1/A actually equal to A inverse. Same thing. Okay. So that's why we put inverse, because this is matrix. So now you have XS equal to SI minus A inverse B US. So finally we have 2 steps more before we can finish the class. YS, so C, the XS here equal to this one, SI minus A inverse B US plus D US. And then after that you factorize the US because we have US and US. You have C, SI minus A inverse B plus D US. And finally you get YS over US equal to C, SI minus A inverse B plus D. So this is the formula.